Hello and welcome to 6.5, the Law of Cosines. Now, we had this sheet that we were organized, right triangle trig, Law of Sines with non-right triangles, and then today we're going to talk about the Law of Cosines. Much like the Law of Sines, there are three different ratios. We're going to have three different equations for the Law of Cosines, and hopefully it's obvious that when we're talking about the Law of Cosines, we are using the cosine function. So the first equation, we're not going to derive it like we did the law of sines. It's a lot harder to derive the law of cosines. It is fun, but ultimately, here are just the equations for them. It's going to resemble the Pythagorean theorem. A squared is going to be equal to b squared plus c squared minus, so this is the added part. This is your Pythagorean theorem. We're going to add this next part, minus 2 times b times c times the cosine of A. Now, personally, the easiest way to remember this is whatever letter is here is also the angle for cosine. Okay, so the other variation of this is if we start with b squared is equal to a squared plus c squared. So it's the same letter combination because whenever we're talking about triangles, we always have A, B, C, side A, side B, side C, and it all corresponds to this triangle, okay? So, a squared plus c squared minus 2ac. If you notice, these two, A, B, and C, are the two letters here. Same thing happens here, AC, AC. So there's some commonalities here, times the cosine of B, but it's the angle B this time. And hopefully you can piece this one together. C squared should be equal to a squared plus b squared minus 2 times a times b times the cosine of c. Just like the other two equations. So these are your three equations that you need to know. If you know one of them, technically you should be able to do the other two because it all follows kind of the same pattern. Okay? And this is best used. So I'm going to put this here. Kind of ran out of room, so I'm going to put this here. Best used when you have one of each letter. What I mean by that is, you'll see in the first example. So it's kind of this little bubble sheet. Unlike the law of cosines, where the law of cosines is used when you have two of the same letter. In other words, this one, you don't have any of the same letter. You have one of each. Okay, 1A, 1B, 1C. Okay, so all these were examples of our law of sines. Here's our law of cosines. Let's do our first. We only have two examples of the day. So let's organize this information just like we have been doing. A is equal to 5, B is equal to 8, and C is equal to 12. Notice we have all three sides, so this is our side variation of this. We want to solve for all of the angles. So I'm going to say angle A is equal to, angle B is equal to, and angle C is equal to. Now, in this particular problem, we're going to solve for all of the angles, and we could use pretty much any iteration of the law of cosines that we want to, because if we're working with the a squared version of it, angle A is involved. If we're working the B version of it, angle B is involved, and C with C. So let's start with A, okay? We're going to use a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. So it's plugging everything in. We get 5 squared plus 8 squared plus 12 squared minus 2 times 8 times 12 times the cosine of A. Ooh. This is supposed to say an equal sign. And we could start calculating some things. 5 squared, 25. 8 squared, 64. 12 squared, 144. All of this should multiply. Let's find out. Oops, let's clear all this. 2 times 8 times 12 is equal to 192. So this is minus 192 cosine of A. So very, very important that this is all one piece. Okay? So add these two together, we get 208. We get 25 here is equal to 208 minus 192 cosine A. The reason why I say that this is all one piece is because some people are going to be tempted to subtract these two. But you cannot do that because this is one term. So we actually need to subtract 208 first. Minus 208 minus 208. And we end up getting 208 minus, oops, that's not minus, minus 25, negative 183 is equal to, these cancel out, negative 192 cosine A. Now we need to get the cosine by itself. We divide by negative 192. So negative divided by negative is a positive, so in my calculator I'm just going to divide this number by 192. And we get this value. Now, since this is only 5 or so decimals, you could keep it like this. That's perfectly fine. Or you could leave it as a fraction. I personally would leave it as the fraction here, okay? So this becomes 183 over 192 is equal to cosine of A. Now we need to get rid of the cosine, so we do inverse cosine. Inverse cosine, and this is the reason why I say leave it as it is, because you're going to get the most accurate answer if you leave this fraction as it is. So plugging this in, inverse cosine of 183 divided by 192, and we get a value, an angle, because we're solving for angle A. Angle A is now equal to 17.61 degrees. Okay, and I'm going to plug that in here, 17.61. Now, we could do this. We would repeat this problem for angle B and angle C. But if you had a choice to work with the law of sines and the law of cosines, I would hope that you would choose to work with the law of sines, because it's a lot easier to work with than this long equation. Look how many steps there were. So at this particular point, we should realize, oh, I have two of the same letter. When you have two of the same letter, we could use the law of sines. And that's what I'm going to do. I'm going to do that to solve for B. So, using the law of sines now, law of sines, we could solve for B. So remember the law of sines? Sine A over A is equal to sine of B over B. So plugging the pieces in, sine of 17.61 over 5 is equal to sine of B over 8. Multiply both sides by 8. 8's cancel. And then now, if you really want to, you could just do inverse sine right here, inverse sine here. All of this goes inside the inverse sine. Sine and inverse sine cancel, and we get angle B should be equal to, and let's plug this in, inverse sine. Hopefully, please do this with me. 8 times the sine of 17.61, close parentheses. Divide that by 5, close the parentheses again. And we have 28.95 degrees. So this is 28.95 degrees. Okay? So, once again, we're able to use what we previously known. The 17.61, 28.95 for the law of sines. And now, if you notice, we have 2 out of the 3 angles. So, to solve for the third angle, we could just add these 2 angles up. So, we do 28.95 plus 17.61. And then we take that value, 180 minus 46.56. We get 133.44. And now we have all 3 angles. in this triangle, okay? So that's how you use the law of cosines. You have one of each letter. In this particular case, we have all three sides. Let's take a quick look at another example. And let's say we want to solve, okay, so here's our example. A is equal to 46.5 degrees, B is equal to 10.5, and C is equal to 18. Let's organize this information. A is equal to, we don't know. B is equal to 10.5. C is equal to 18. Angle A is equal to 46.5 degrees. Angle B, we don't know. Angle C, unknown. Now, this particular case is different than the first one. The first one we were allowed to do whichever case we wanted because of the fact that we had all of the sides. This case we have actually, so if we drew this out, let me draw this out really quickly. Let's call this A, B, C. We have side B, which is 10.5. Side C, which is 18, and then angle A, 46.5. In this particular case, this is side angle side. Okay? If we have side angle side, that means we actually have to use one specific equation. The equation that has the angle A in it. So looking at our equations, here they are. Looking at our equations, there's only one equation that has angle A involved. And that's the equation we have to use. So you look for that angle. It's a side angle side equation. You look for that angle, and you solve for it. So let's do it. We're going to have A squared plus, or is equal to, B squared plus C squared minus 2BC times the cosine of angle A. So this is going to be nice because everything is on the right side of the equation already. We have A squared is equal to B is 10.5 squared plus 18 squared minus 2 times 10.5 times 18 times the cosine of 46.5. And the nice part here is you could actually just plug this into your calculator as you see it. 10.5, and let's, 10.5 squared plus 18 squared minus 2 times 10.5 times 18 times cosine 46.5. All of this can be plugged into your calculator right away, and you should get this value. A squared is now equal to 174.05, approximately. Now square root both sides because you have to get rid of the square. A is now equal to, I'm going to do this, square root, second answer, and takes up most previous answer. We have 13.19. And now we have 13.19 here. And we are in good shape. Okay? Try to solve for these other two. I'll give you a hint. Once again, we have two sides, or two of the same letter, so now we could use the law of sines. So try solving for angle B, and then once you have that, you should have 2 out of the 3 angles to solve for angle C. Okay? So give that a shot, and I'll see you in the next one. If you have any questions, please let me know, and I'll happily answer them. Bye.